Welcome to this panel session that is being put on by Duolog. Thank them for all of the planning that they've done to try and put this panel together. My name's Brian Bailey. I'm the editor for the EE Times EDA design line and a contributing editor for EDN. So I'm not an expert here. It's sort of, these are the experts, so we're going to try and get a discussion going, and I hope all of you will be interactive within that discussion. So the title we got is IP Packaging, What's in It for Me? And of course, with something like this, there has to be multiple perspectives. I was on a panel yesterday that was on modeling. And one of the biggest issues that came up there was the user companies wanted every model you could think of. And the model providers said, but if there's no ROI, then why would we ever create the model? And I think it's very much the same with IP packaging. We can start defining what the wonderful ideal situation with packaging would be for IP customers, but that's a very different story than when we turn it around and look at the IP developer. But you know, one of the things that's fairly clear, I think, is that the notion of packaging is perhaps something that hasn't really been addressed too much with the IP industry. So that kind of constrains the ease with which we can start selling it as a complete entity in and of itself. It's what should come with a piece of IP. Is it just implementation? Is it verification? Is it abstract models? What do we really need in order to define that IP as a complete package that can be used by various people? So there's many ways that we could start thinking of IP blocks and what it means to actually deliver and integrate that into a system which people can use. So I'm going to give a very quick introduction to our panelists that we have here, and I have to admit that there's one of our members of our panel here that I wasn't even aware that was going to be in our panel until I turned up here. And I've never met this guy before. So,
Neil. How you doing?
hi Neil, it's very good to meet you. So I'm going to let you introduce yourself.
I'm Neil Hand. I'm with Cadence Design in the SoC Realization Group, which is the part of Cadence that's responsible for design IP.
Thanks. And next to him we have Adam. Adam is the General Manager of the Chip Planning Solutions team at Cadence Design Systems. Let's face it, we still don't know you as Cadence. It's ChipEstimate.
I noticed that. It is.
Exactly.
That's right.
So we'll keep calling him Adam from ChipEstimate. Okay. Then, of course, we have Dave Murray. He's our host in some respects for our talk today. He's the CTO of Duolog. And prior to Duolog, he was the founder of Inora, senior engineer at Toucan Technologies and Silicon Software Systems. He's written many papers on the subject of SoC integration and verification, and has his own blog titled Integration Insights. Now, it's actually interesting on the panelists of, you know, we really are quite diverse in where we come from, with quite a lot of preponderance to the other side of the Atlantic Ocean. And I note that Dave has a Bachelor of Engineering from the University of Limerick. So, do they actually teach you engineering in Limericks?
Do you want me to quote you one?
Of course. Let's start off with a little bit of fun here.
No, well, it actually just makes learning things easier if they rhyme.
Okay, so in other words, everything in engineering should rhyme, and if it doesn't, then it's an incomplete limerick.
Yes. They start off, there was a young man called Bailey.
Really?
Yes.
Okay, and where does it go from there? I don't think I want to know. Okay.
Downhill.
Probably. And at the end we have Grant Martin, who's a chief scientist at Tensilica. I've known Grant for many, many years, and Grant was probably my teacher when it comes to cutting my teeth on writing books. Grant and I actually wrote a number of books together, and I know Grant is actually proud that one of his books was translated into Russian, that he still hasn't managed to finish proofreading yet. But I'm sure one day he will. Okay, so they're our panelists. So what I would like to do is to just go down the line to start off with and ask each of the panelists what to you is either the biggest opportunity or the biggest problem when it comes to the notion of IP packaging? Do you want to start, Grant?
Spasiba, Brian, spasiba. So when it comes to IP packaging, we have our own definition of IP, because most of the IP we sell is configured processor IP, where people use our processor configuration flow to generate what kind of processor they want, its characteristics, and what's possible to add instructions to it. We also have subsystem IP. We've defined over the years our own package of what is required to do that, including the RTL, compilers, software tools associated with that, and high-level models, including System C models and models. There haven't been a lot of standards, so it's really been driven by what we feel designers need in terms of the models, the representations, and the documentation in order to successfully integrate that IP. So we haven't seen a burning need to define a truly standard industry packaging methodology yet. Although, because we want to help our customers, we are of course interested if one emerges, we will immediately try and support that in our IP configuration.
Thanks, Grant. Dave?
Yeah, I think there's, I suppose, with our customers who basically, their requirement is by their customers is to package up IP so that it's easier to integrate, etc. There seems to be a few problems or even concepts that are philosophies, I should say, that are troubling with that. What we find is the packaging of IP metadata is an opportunity seen from the integration side to be able to integrate that IP easier, but it's seen sometimes from the IP provider to be an overhead. So in other words, that you've designed your IP and then you're packaging up your IP metadata, you're providing a deliverable, and in order to make that IP more integratable, you need some type of an executable spec for this IP to bring along to the integration provider. And what we're finding is that if we can bring the IP packaging to the very start of the process, the IP creation process, then there's a lot of automation that that people can actually get out of their IP creation flow. That means that if they specify, the hardware-software interface or the hardware interface, then it's actually easier to generate a lot of the IP design collateral. So I think the opportunity is that it's very, very good benefit for both both having your IP more integration ready, but also to automate your IP creation flow. I suppose the challenge is what Grant was saying here sometimes is what standards are out there. So I know that there's IP Exact is a standard that exists out there at the moment, but the use case in terms of actually how do you define IP that really is interoperable, that is easy to integrate, that's still quite early on in the flow. And I think the challenge is to come up with better, the standards are there, I think better use of the standards, better sharing of the best practice of these standards in order to be able to package up your IP properly.
Adam.
Thank you, Brian. So from the ChipEstimate.com perspective, we're constantly talking to thousands and thousands of chip designers, and then we also get the other perspective from the IP suppliers within the ecosystem, and also from the foundries as well, many of which have their own IP. And I think the real problem with packaging is that it all comes down to incentives, kind of along the lines of what you were saying earlier, Brian, when it comes to what are the different ROIs for the different parties involved. I used to be a chip designer. I used to buy third-party IP. IP integration is a huge problem. Standards would be very helpful. New standards would be helpful in this area, I think, from a designer perspective. But the problem is that creating those standards requires the participation from the leading IP suppliers. And the incentive for them to go and conform to these standards or to participate in the development of these standards isn't always there. Brian, you mentioned the ROI before. I think I think that's part of it, but I think a different part of it is actually it reduces barriers to competition, right? So if you look at a lot of the work that had been going on over maybe, the last 5 or 10 years, it started with the VSIA, the FSA, and then the GSA in IP quality. This is another good area where everyone agrees there's a huge problem, but we can't come up with standards. They haven't been adopted because it actually works to the disadvantage in my opinion, of the IP suppliers. It reduces the barriers to competition. It makes it easier to compare products. It makes it easier to swap out products as well, right? Granted, from a perspective of a processor company, I think there's a lot of software and ecosystem that goes around, a Tensilica core or an ARM core or something that helps to enable more fortressing of your customers, right? But when it comes to other kinds of IP, whether it's a PHY or some sort of a standard interface IP, it becomes even easier to swap those things out when more standards exist. And so until we get to the point where the users are just demanding these standards from the IP suppliers, I don't see a heck of a lot of incentive for them to go and participate in the creation of them or support them.
Thank you. Neil?
So I think the original question was, what's the opportunities and what's the downside? So if I do them in the opposite order, if you look at the downside, as everyone's mentioned, there's a lack of standardization. There's clearly something broken already in the integration flows. It takes too long to integrate. There's something that is wrong there. Now, will standards solve it? Probably not, because what really is going to drive it is, as an IP provider, we get differentiation out of implementing these things. We spend a lot of money in our infrastructure at Cadence to build the types of tools you were mentioning that generate automatically the various views. And so with our memory controllers and enormous amount of configurability, we automatically generate the verification environment, we automatically generate the documentation, we automatically generate the RTL code, the regressions, everything for a very specific custom deliverable. As we add new views to that, what's going to drive us to do it is, does it give us a differentiation? So, some of the ones we're doing now is we give views that are system integration views that help with packaging and topology, not packaging from an IP packaging perspective, but silicon packaging. So we're investing in that and we're adding it. Likewise, at firmware views, with System C views and those other types of views, and what the deliverable package looks like is what's going to drive it. As opposed to the metadata standard, which really, the question becomes, it's a chicken and egg problem. Someone has to know how to consume the data, and so I think what's going to end up happening is, what views are available, what views do you provide, and then how do they go into the integration tools themselves? Because I think today there is a lot of different ways you can explore and understand the design, whether it be through the chip planning type of tools or various other ways of comparing it. And so I think the opportunity there is differentiation, and you can differentiate through IP packaging. I don't think it commoditizes the interfaces. I think it actually gives, in many ways, greater visibility into the differentiation that people have. So I think it is a net positive, but it is something that is, you're not going to invest in it all up front unless there's someone going to be consuming it.
Go ahead, Grant.
Just to follow up on that, the primary thing that motivates us adding a view to our package, our export package for IP, is customer demand. And I've been at Tensilica for 8 years, and in 8 years, 2 cores have asked for example, an IP exact view. We almost wrote a generator, but we wrote them by hand in a couple of days, provided them, and we keep waiting for demand to occur, and then we'll write a generator because it's very easy to have our infrastructure to just do that for another view, especially a relatively simple view. But the demand just isn't there. I actually think integration is not a primary issue for our customers because they're dealing with fairly complex IP and processors, especially when they configured it and extended it themselves. The evaluation cycle is long because there's an awful lot you want to do with the processor. So you're into software, you're into system modeling, you're into higher level design trade-off kind of issues, which we try and support with the various deliverables. But the actual integration process itself is not simple.
Right. We say Adam kind of mentioned the chain of failures in the standards groups that have been trying to tackle this, and I know, Grant, you and I go back to the very early days of VSIA, of trying to tackle some of those there. Is it because we don't really understand the problem enough to be able to create a standard yet, or is there something else happening here?
My fundamental thing is that there isn't that much of a problem when you come to complex IP and subsystems with the integration itself. The metadata is useful, and people can get that type of IP we provide, but it's not an absolute barrier. There are much higher level, much harder problems, including the issue of, okay, you've sold me a complex, or you're trying to sell me a complex subsystem of multiple processors interconnected other blocks. What speed is that going to run on my FPGA when I mix that in with my own IP and multiple other subsystems I have from other places? That's a much, much bigger problem. And as an IP provider, we can help and support that. But ultimately, you can't answer that question. The designer and the design team have to answer that themselves. Those are the big problems.
Okay, I know Neil's chomping at the bit here.
Well, I would disagree on the point of view that the integration is not a problem for customers, because it is a huge problem. We see with our customers every day. I think the bigger challenge is every customer has a different design environment. Every customer has a different integration environment. And so before you can standardize on the IP packaging, the question is there's no standardization in the underlying methodologies. There's no standardization in how we bring this stuff together. And so that makes it very hard then to say what is needed in the IP package, in the standardization. IP Exact has been around for a long time and it hasn't gained traction, partly because how do you use that data? Where does that, how does it help the flow? And so what we tend to see on a day-to-day basis is people are addressing it from the bottom up, where you can actually take a view that solves a particular problem that can be genericized across the flow and bring that together. So it's part of what is the standardized views, but the difference is that because of the lack of commonality in the underlying methodologies, you can't really build an integration, a standalone integration package.
Yeah, I would tend to agree with Neil in this as well, and because we had a panel session here yesterday, and integration is seen as a major problem. I mean, we've got EDAC saying it's one of the biggest challenges for EDA to solve in the coming years. We've Semico Research saying that it's one of the costs to the increasing costs to socket design in terms of just the ability to integrate IP. So in terms of that, again, I think that the ability to deliver to customer IP that is easier to integrate into an ecosystem that can be a range of different methodologies, flavors of verification, etc., is a differentiator in itself. The problem is, again, it's not so much what we're seeing is it's not so much the IP Exact standard itself; it's the usage of it. In other words, if I need to package up my IP, how am I going to package up information that can be translated basically to these integration environments? And I think the challenge there is to actually come up with better use models. And like what we see actually is there is a streamlining at the moment of IP Exact and something like UVM, whereby IP Exact can be used to generate a UVM register models that can be shipped along with an IP that can be then used to test at SOC level that this actually works. And again, does it matter what environment you're working on at SOC level verification? Maybe not, but at least you've got a UVM methodology there is designed to link with this. So that's one of the, if I as an IP provider can actually provide an easy path to the integration of my IP, that can become a differentiator.
I don't think this makes a lot of sense, though. We're hearing that it's a huge issue from some of us, right? But at the same time, people like Grant are telling us that the actual customers are not asking for the views that would enable a more efficient integration process. So who's at fault? Where's the problem?
Well, I think the issue depends on the type of IP. So once you get to a subsystem type of IP, a lot of the problems go away. So the advantage of subsystems are that they become easier to integrate. You do have standard ways of interacting with the firmware. You have standard ways of putting it all together. All of the integration work has been done. So a lot of what Grant was talking about was at the subsystem level where you're putting things together. You mentioned earlier about PHYs and controllers and being able to transfer those in and out. For them, there is a huge integration effort. But it is also, to the point that David made, it's a great opportunity for differentiation. One of the things that we focus on with our IP is delivering ways to make it easy to integrate. And it does enable differentiation. We've been able to make a significant impact in certain areas where we have made it easier for people to integrate. We've given them views for the system level design, the package board, and it does help, but it is being driven by what is the customer asking for, as opposed to, okay, what's the idealized scenario? Let's go build the idealized scenario, because ultimately when you invest in the ideal scenario, it turns out to be not ideal.
Right. If anyone was at the high-level synthesis panel this morning, there was something that came out there that I thought was kind of very surprising. and without looking at my notes, I can't tell you who it was who said this, but it was somebody who had been evaluating the use of high-level synthesis, and they said, it's wonderful. It produces, huge productivity gains for the block, but we lose all of that when we now try and integrate that block into the rest of the system, because now we have to worry about clock gating, power, all of these other issues that are all part of that integration process. And so I think this is more than just an IP packaging issue. It just seems as though it is an integration issue at large in the way that we're designing and constructing chips, systems, SoCs, that has much bigger ramifications than just the delivery of IP. Does that make sense to people? Or, so are things like clock gating and power gating issues that we're completely missing when we just talk about IP exact or what have you? Because that's not metadata, that's real functional transfer of information about the interface and the capabilities of the block.
So I think one of the key things is, you're exactly right, that's why a few times I've mentioned views as opposed to metadata. And the views capture that type of thing you're talking about. It does capture what is my clock gating, what is my register map, what is my verification IP. And I think that really is where it's going to be driven from, as opposed to what is a metadata-driven thing. Now, once you have all the views, you need a way to communicate that. And so it becomes a secondary item.
Right, so that almost says that, a high-level synthesis process, it's not adequate for it to just be generating a piece of RTL. It has to be generating a whole bunch more information about how that block can get used within the context of a larger system, doesn't it?
It does, and I think the opportunity for high-level synthesis is the ability to generate those. I know previous lifetimes I've worked with high-level synthesis tools back at Get to Chip and other places, and with that, what it did generate those models, and you can do it. And I think probably, Tensilica can talk to it, but I think I would be very surprised if their generators don't generate those types of models for their scenarios.
Okay, who's going to take the mic over there? You're fighting over it.
It was the feedback. So what I wanted to say is that it fits along with what you were saying about high-level synthesis, etc. There is no standardized IP and subsystem and complex block out of high-level synthesis integration methodology or tool flow that people can really use, or that has become semi-standardized among, say, the major EDA vendors, that would then allow the virtuous circle of, once you have a semi-standardized integration approach and some tools to support, then the demand for the standard representations and views and models to fit into that will come, and it will feed on each other in some way. Many years ago, when I was at Cadence working on the Alpha project, we developed an approach to an SoC design methodology based on platform-based design, etc. And we suggested to our colleagues in Cadence that having an integration tool that fit in with this kind of concept might be a good thing. Well, that was 8 years ago, and I'm still waiting to really see these kind of capabilities emerge. When and if they do, and if there is some commonality among them, then I think this virtuous circle of demand for the standards that will allow things to be integrated more easily into them will begin. But it hasn't quite begun yet. It's still more ad hoc and manual.
Yeah, I think what we're seeing in this, at the moment working on an Accelera, the IP Exact Technical Committee, what we're seeing is something that Neil mentioned there, which is, like, there are these different views and they need to be communicated. What we're seeing is that there's like little nodes opening up in IP Exact to start putting in information about power, information about verification, information about the hardware-software interface. So we see that it's become almost, it's becoming the storage vehicle for communicating this type of information. And again, so what's happening actually is rather than an explosion of the standard, what's happening is we're trying to create containers for these information called standard extensions. And this is what we're seeing is the need for these, that people want to package up power information, power intent information as part of the IP, but also verification views, a lot more than just the standard hardware view that people traditionally associate with something like IP Exact. And again, this information is allowing, once it gets into the standards, what we're seeing is that this should allow tool providers like ourselves, who are focused on delivering integration solutions, the ability to, once these IP are in a system, the ability to extract that information and provide an easier path to integration of these within these, across these different views. So be they a TLM view, power view, the hardware-software integration, actual RTL assembly, so all those type of views to help the integration process there, because the integration process is many different domains.
So I'm still a little confounded by all of this, okay? So thinking from the chip planning and chip estimation perspective, I'm hearing all the time from customers who are using our chip estimation environment that they need tools to help them, for instance, with automated IP assembly, where standards like IP Exact are meant to enable this kind of auto creation of a front-end design by virtue of connecting up all this IP together. It's a big problem. They need it. It's an inefficient process today. It's manual, and this is part of IP packaging. But here's the problem. They want it, but they won't pay for it, right? Way up at the front end of the flow where we are talking about doing all this stuff, the value of tools is actually quite a bit less. And so one of the big challenges, again, back to what I was saying before, Brian, about incentives, is that there's not very much incentive for the EDA providers to provide these types of tools that then consume these standards that may be part of what the package itself is for the IP. And so until we can get to that point where the design teams, the semiconductor companies are willing to pay for these products, I still see a huge barrier there. To me, it keeps coming back to the business challenges versus the technical challenges that that our users are facing on a day-to-day basis.
Yeah, actually, I think some perspective I have on that is that you're right. There is a problem, even like if you're like looking at the chip estimate portal, all the IP. Someone decides, okay, I want this catalog of IP. I want to actually create a chip out of them. The actual hookup, the proper, correct, and fast hookup of that is a major challenge. And what we're seeing is that we're using the IP. We have flows that will allow us to integrate a chip like that in an extremely short space of time. So we're trying to basically bring it down in terms of days than weeks. Now, the thing is that I think that there is a slightly hard sell if we talk about packaging, because the only reason that someone then will package up their IP is for the benefit of the IP consumer to help them integrate.
Right.
But what we're seeing is, if we look at the information that will enable that integration, and actually if we jettison this to the front of the flow, then that information will not only automate the integration, it will also automate the IP creation part. So I think, so what we see is we're providing tools for packaging, but our customers are, and basically the integration consumers within the company, if they have third-party IP, are getting very good benefit from that. But now those IP providers are actually getting a benefit from bringing this packaging to the start of the process, and they're calling it IP standardization. And I think that's basically where the differentiation happens. So I agree with you that who's going to pay for something that is going to be, it's an overhead for me, if it's, I call it packaging, and yes, is the integration team or is the integration budget, or is that going to pay for my for me having a tool to do better packaging? But and that's actually a difficult sell. But if those two teams can actually get a value add in terms of in their own flows about having that metadata. So for instance, we package up registers, we define registers, etc., and straight away we produce documentation, UVM register package, a TLM model, etc. That basically for small IP, and I've seen there's various, it goes from the PHYs to the massive subsystems. We did an analysis of some of the IP, and sometimes the hardware-software interface is 60% of the actual implementation code across TLM, across the documentation, across this. So if you can bring it out to the front of the process, you can automate this. And this is so for us, this is where the interest is in terms of packaging.
Ron, go ahead.
Yeah, actually, I'd like to come back to Adam's point about the perverse economic incentives in the EDA industry. I think actually it is true if you look at it. Synthesis, the automatic creation of something that you find hard to do manually, attracts the most economic economic incentive to follow the money. Synthesis first, verification second, because it's fundamentally a de-risker and an ability to do things that you really can't find any other way to do than by verification. But when it comes to IP integration, it's one of those things where design teams can muddle through without a lot of tooling.
Exactly.
So from the management perspective, I can see in a large company, oh, we'll just throw 5 more people and they'll cobble the thing together and they'll get it to work somehow. We'll pay for their synthesis tools for the logs. We'll pay for verification so you can see if the whole mess works together. But when it comes to the front-end tools, the economic imperative isn't there. Until either the design group's down tools or just give up because it's impossible with the scale of designs, there probably won't be a big enough economic incentive to really let this take off. But that kind of complexity seems to be coming, and who knows, maybe it will happen.
I actually find it interesting that we're seeing larger and larger IP blocks and subsystems coming out of Synopsys, Cadence these days, and it's as if they're taking on the burden of the integration so that the customer doesn't have to. So in answer to your kind of issue there, Adam, it's Cadence obviously sees the value and is willing to pay the cost of doing that integration because they then believe that they can pass that cost on in terms of higher value IP, and part of that higher value comes from the fact that it has been integrated. So ultimately the customer is paying.
I would say in that case, you're right, Cadence is making that investment to make their IP more differentiated and worth more, to Neil's point as well, right? But that's where they're choosing to spend the money, not on the creation of the tools to enable the customer to do it, right?
So obviously within Cadence, they believe that the economic incentive right now is to do it manually rather than to create tools to do it automatically.
Right, I think the incentive for them is to boost up the value of that IP, and keep in mind, we're talking Cadence breaking into the IP market here, right? Haven't been doing that for the last 20 years like other folks, right? So any incentive to create higher value is a benefit there. But we're talking about packaging, we're talking about the challenges that our customers are facing in packaging. I don't think that, like Neil said originally with the chicken and the egg problem, I don't think we're going to get to that point where the incentives align, like Grant is saying, where the pain threshold is high enough to create the tools to consume these standards. And you're exactly right. And so what will happen is that the onus will fall onto the IP suppliers and the foundries, as they're doing now, to basically build that value in. I mean, these days you can piece together a chip with, you can buy such large subsystems that are out there, right? You don't have to do nearly as much because a lot of the work has been done for you. The building blocks are getting bigger, basically, right?
Yeah, and I think if you're correct. From an IP perspective, we invest in making the IP as integratable as possible in as many scenarios as possible, which means any customer, regardless of design methodology, regardless of their design flow, their tooling, can take the IP and get it into their design. We have to do subsystems because with the complexity of the designs, they've got to go bigger. The blocks have to get bigger. Now, that is a different set of challenges than what everyone's been talking about. If you think, one way of looking at it is you speak to customers and hope springs eternal. Every time they start a new design, they start getting a new group of IP, it's like, this time it's going to work. This time it's just going to be a text file, hooking all the ports up, and it's going to spring into life and operate correctly. And so that's what they believe is involved to do that. The reality is usually very different, but as Adam was saying, it's very hard to convince the people up front that you need specialized tooling to do that. But we are investing in making sure that the IP is highly integratable. We already do some of the things David was mentioning with the integrate upfront automation, where the definition of our IP, which our customers get to do through highly configurable, and everything else generates afterwards. But then the packaging goes back to what this whole discussion's been about, is with a lack of standard for the packaging, a lack of tools for the packaging, and a lack of motivation for people to adopt those tools, what will a standard do? IP Exact's been around for a long time. There's been a lot of tools built to do IP assembly with IP Exact. How many of them are used today?
Well, I can comment on that. We've had our busiest DAC ever, with a lot of people looking for IP standardization solutions and integration solutions. So this is my only pitch, okay? And it's not really a pitch, it's a direct answer, okay? Yeah. But I think, one very interesting use case as well then would be, look at like interconnect fabrics. Okay, that is actually you could say that's actually the exact same thing. It's an IP that is, you can say, that's designed to help integration. So and again, the thing is, are people using? Yeah, people are using fabrics now. There's fabrics providers. There's an ARM has the NICs. There's the Sonics and there's the Artors, etc. So these companies are actually, their lifeblood is integration, if you look at it like that. So the thing is, but again, now even with the fact that these are actually highly configurable, that Cadence IP is highly configurable, etc., it's still very, very difficult to hook these together.
No.
And what's happening is we're looking at solutions to actually do that. And again, this is getting very popular because integration is a big problem.
Oh yeah, so I'm not debating integration as a problem. I think we need, back to the original thing, what is the opportunity with the standardization of packaging? I think it is a big opportunity, but it does become a chicken and egg situation of, for us to generate a standardized packaging for IP is actually relatively simple. We've got all the infrastructure in place, but the question is, which standard? And we do look at IP exact. We've had discussions, which ones do you use? And I think it's a good opportunity. But to Adam's point, there's this, what's going to consume it? What's going to use it? How do enough customers use it today to make it relevant?
Actually, the idea of interconnect and integrating IP is really interesting because it automatically gets you into the standards for it, which are very often proprietary or unique, or maybe within an individual company. For example, if you're using an interconnect standard, what kind of buses and bus bridging are you using to get into that? Is it native to the IP, or is it, as is by far the case today, some variation of ARM-AMBA, AXI, etc., that people are using in the interconnect? Then the interconnect itself may be configured by an automatic tool. But we're still ignoring, if you like, the enormous elephant or gorilla in the corner of the room, is what customers really want to know.
Was he looking at you?
It's the invisible one right behind, the one going up to the ceiling. What customers really want to know, when I take, say, all your processors, all these blocks, all this interconnect fabric, now I want to program this whole thing to do something, like be a baseband subsystem, be an audio subsystem, do some kind of imaging and video processing according to these standards. Where's the software coming from? And how can I really be sure that this whole assembly put together is going to work? That's what leads to the very long evaluation cycles, and if you like, a lot of the uncertainty in the customer base. It's not just, in fact, the individual IP blocks or the standards or hooking them together. It's putting the whole thing together before they come in that I think causes a lot of people some concern and trepidation, and I don't see much in the horizon of ways in which that can really be made easier. There's certainly some thoughts, but I think...
Well, let me rephrase that as a question for everyone, and I think it might be our last question. If we could completely skip the whole notion of the standards process, which can take years and years and gets very political, if we could create a standard right here, right now, on the Duolog booth at DAC this year, and by the time we finish this question, the standard's created, what would it look like and what would it do?
I would say it doesn't matter because nobody's going to adopt it.
Many years ago, I worked with Jim Rosen, a very intelligent person, who said, de jure standards never work. De facto standards that are invented by users or demanded by users are the only ones that really count.
That's
So
right.
I don't know what that standard is because I don't think the demand's built up yet for it. So I can't say that the standard is the solution. Whatever users coalesce around demanding will be the solution. And it emerges. When it emerges, we'll try and adapt to it as I'm sure everyone else.
It's an interesting question. I mean, I think from the issues that our customers have, I think the ideal for us we'd see is basically a very extensive model of an IP that covers all the different views, and again that also that abstracts where it needs to abstract. In terms of if there's something that if there's a concept that exists that needs to exist in TLM views, etc., it needs to be automated. So the actual content, we could spend the next few weeks talking about, etc. But it's not. The standard is two things for me. One is the format of what you communicate, but it's also the best practice. It's like the going that the chip estimate customers would basically have a set of guidelines and say, look, this is actually how to use it. This is how you package. That's not even that's beginning to mature at the moment. I mean, we're seeing even at this stage, as in right now, there's basically sets of bus definitions that are going to be published that are going to be standardized across the industry, so that when Cadence packages an IP, or when Grant packages IP, or ARM packages their IP, or any of the chip estimate customers package IP, the intent is the same. So that is beginning to grow at the moment, and I would see that type of information needed to be part of the standard as well.
Yeah, I'm struggling in my own mind how to answer your question, Brian. But based upon what our customers are telling us, I guess I think two things here. I think that the automation of IP assembly, where you guys are focused on, David, I think is the right place to solve the problem if we were going to do something here today. But I also tend to really agree with Grant, which is why I struggle with it. It's not us that need to be defining these things. It's the end users. They need to be telling us where their highest pain points are so that we know where to focus. And right now, I think that whether or not we all agree that IP packaging is an issue or IP integration is an issue, there are bigger problems out there. And so I think that users are going to end up telling the EDA suppliers, telling the IP suppliers where their largest challenges are. I'm just not convinced that this is going to, in the next few years, even though IP is becoming more important, even though we're seeing a huge increase in adoption of third-party IP, I think that there are other barriers or other complexities that are growing faster than the integration challenge.
Just to end on a different note, I would give it, and expanding on from what Adam was saying, the answer is it'll probably look like whatever the software guys want. Because if you look at the software problem in an SoC, it is getting out of control much harder, much faster, than the IP integration at the SoC level.
Yep.
And so whatever allows them to do the IP, the software integration and the software integration with the SoC, it's most likely going to be what gets driven down and pushed into the IP assembly, because they're the ones that are going to drive what does my program model look like. That's going to define the program model views. That's going to then be a requirement of the IP providers. And realistically, I think we could sit here and pontificate all day. It's going to be the software guys that are defining it.
Okay, well, thanks very much, everyone. I think the message that's coming through here is that this is going to have to be a cooperation between IP providers, IP users, and primarily the need has got to come from the users in establishing what their needs are and what are the problems that they actually want solved. So please join me in thanking all of our panelists today.
Thank you, Brian.